Hello and welcome to a short video about solving linear simultaneous equations. So when we have simultaneous equations, we have two or more equations that are given together and the same values make both equations true at the same time. So we've got an example, 2x plus 3y is 41 and 3x minus y is equal to 12. So we need to find a value of x and a value of y that make both of those equations true simultaneously. Now the first thing I'm going to do is multiply by the other number of x's. So if I'm looking at equation 1 here, if I look at the other equation, there's 3 x's, so I'm going to multiply by 3. If I look at equation 2, in the other equation there are 2 x's, so I'm going to multiply by 2. So when I say I'm multiplying by 3, I'm going to multiply everything by 3. So that's going to become 6x plus 9y is equal to 123. Similarly, for equation 2, remember I'm times by the other number of x's, so I'm going to times everything by 2. So I'm going to get 6x minus 2y is equal to 24. And the second step, the second thing I'm going to do is a takeaway. I'm going to take away the second equation from the first equation. And if you've done step 1 properly, it will always be a takeaway. So 6x take away 6x is nothing, and that's why we want to do it. We're getting rid of that variable at the moment. Now be careful with questions like this. 9y take away minus 2y is 11y. It'd be very tempting to put 7y as 9y take away 2y is 7y. We have to remember we're taking away a negative number, so we're doing 9 take away negative 2. And that equals 99. 123 take away 24. And I'm going to solve for y. So y is equal to 9. My next step, the last thing I'm going to do, is substitute this value back into one of the equations. And it doesn't matter which one you use, because remember, it's worth 9 in both. So I'll just use the first one. 2x plus 3y is equal to 41. Now instead of y, I can put 9, because I know that y is worth 9. So 2x plus 3 lots of 9 is 41. So 2x plus 27 is 41. So 2x is 14 and x is 7. And of course got that by taking away 27 there and then dividing by 2. Okay, so to summarise, these are our 3 key steps that we want to take. Multiply by the other number of x's, then subtract and solve for y, and substitute your y value into any of the given equations to solve for x. So just look at another example quickly. This one looks a little bit more difficult because in the second one they've written the x and y the wrong way round, so be careful of things like that. And also notice that the x has a negative number in front of it. So when I do this one, I'm going to times this by negative 4. I'm going to times it by minus 4 because I've got minus 4 x's there. And I'm going to times this one by 2 because in the first equation I've got 2 x's. So when I do that, I'll have minus 8x minus 12y is equal to minus 20. And I'm going to rearrange this. I'm going to put the x's first just to make it easier for me. So when I do minus 4 times 2, I get minus 8x. When I do 2 times 2y, I get plus 4y. And 2 times minus 18 is minus 36. So then do a take away. Minus 8x take away minus 8x is nothing, it goes away. That should always happen. Minus 12 take away 4 is minus 16y. Remember, you can always do that in your calculator if you need to. Minus 20 take away minus 36 is 16. So again, it would have been easy for me to do minus 20 take away 36, but remember we're doing minus 20 take away minus 36. Then solve for y. Y is minus 1. I'm going to then use my value that I've just found and substitute it in one of the equations. So I know that 2x plus 3y is equal to 5. So 2x plus 3 lots of minus 1 is equal to 5. So 2x minus 3 is 5. 2x is 8. So x must be 4. So this method works when you have 2 equations and 2 unknowns or 2 variables. So maybe x and y are 2 different letters. If you have 3 equations and 3 unknowns, you do need a slightly different method that we might look at in a different video. But I hope that helps. Thanks very much.